and cell type, 2A ANOVA. Come on. Chunka, chunka, chunka. Again, there's our top page here. What's our top pathway? Do you guys have the same list? Tell me you do. Okay, good. What's your top pathway? What is it? Yeah. Why don't you put EMT in? Try this. So just to show you that this stuff works, you know, this is obviously our top pathway. Why am I? Oh, whatever. It's our top pathway. Put in EMT and stem cells. See what comes up. Did anybody get the epithelial mesenchymal transition generate cells as your top hit? Click on that. This was in Cell, by the way. Just letting you know. Although, honestly, I'm so sick of like journals now. I think at some point I'm just going to quit publishing and just put my stuff on the web, you know? Might as well, right? I have to go through all the review, you know, why don't we just review these things online? So this EMT transition generates cells with properties of stem cells. We are finding this pathway both affected by cell type and by differentiation state. I just want to put that in the back of your head. Here's what we're going to do is we're going to kind of climb through this data, and you're going to notice themes at each tab. Eventually, by the time we get to the end, you're going to be like, the story will start coming together, I guess. This is kind of the art form. Don't worry if you don't get it the first time. I've been looking at like gene expression stuff for like 15 years now. What I want you to understand is that what we're doing is we're kind of looking at a language rather than just numbers. This is basically the cell this to us. This levels of gene expression are words, basically. And if you look at this, if you pay enough attention to, you know, the analysis, the language starts like popping up. Has anybody read that book? It was called Blink. It was by Malcolm, I can't remember his last name. Malcolm what? Backwell, yeah, I think so. Or Gladwell, yeah, that's the one. Basically, it was a book on, you know, how people can just know something right away without having to think about it. Just that instantaneous like recognition. And his example was there was a statue. It was supposedly supposed to be from the ancient Greek period, but a lot of these guys didn't know if it was original or not, so they brought an expert in. And the expert basically walked into the door. As soon as he walked in and looked at the statue, he goes, "That's fake." And they were like, "How do you know this? What did you know, what is it that," he's just, "I don't know, it's fake. I know it is." Honestly, that's kind of how you get with these gene lists and looking at this stuff. Eventually, you know, I'll look at a gene list and I'll go, "Oh, this is in trouble." Or there's an inflammatory response that's huge, or this thing isn't growing. That's what IP allows you to do, is kind of get to the language of all of this gene expression. And I just wanted to show you that, you know, this stuff works. That these pathways and these networks that pop up, they aren't just random genes, they mean stuff. Okay.